Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on EMC consideration. Okay, so for this video, I'm going to discuss the common EMC test facilities. Okay, in fact, for this video, there are 7 of them, but 5 of them, which is a very common EMC test facility. The first one will be the open area test site, okay, which I think you have some idea what is all this. Next, we have TEM and also GTEM cell. Fourth will be the semi and fully adequate chamber. Okay, so these are the 5 common EMC test facility which we are going to take a closer look later on. We are going to compare, okay, the advantages and also the disadvantages on all these common EMC test facility. So this will be the objective of this video. This will be the part 32 series discussion on EMC. So guys, if you're keen to know more about EMC, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. When more you guys actually help to like this video will have a better chances to reach out to a larger audience. So guys, help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly take a look on the common EMC test facilities. Okay, so in fact, this EMC test facility, they are specialized lab that basically equate to evaluate all the electronics device that require to be compliant with the EMC standard. Okay, so these facilities ensure that the device, they actually operate correctly, okay, in their intent, beside their intent, so-called function, they also must not overly contribute to become a disturbance in the environment. Okay, so basically this is what I mean as an interference. And here are the most common types of EMC test facilities. The first one will be the open area test site. Second, I will do a quick comparison between semi and fully adequate chamber. Which one then we will use for different use case here. Next, this showroom is so-called the less stringent, okay, as compared to the adequate chamber. Okay, so basically for this, we can do the conductor emission and also maybe the conductor immunity, okay, and also the ESD, etc. All this can be done in the showroom. Okay, next we will have this reverberation chamber, okay, which is the Moster chamber. Okay, so basically this is mainly, okay, for a very high magnetic field, for radiate immunity field here. Then we have this TEM GTEM cell. The most of the time when we actually use this, the device need to be very, very small. So basically we have this kind of constraint. And the last but not least, automotive EMC test facility. We are going to take a close look on all these 7 common EMC test facilities. First one will be the open area test site. Okay, so I guess from this diagram, you know how does this open area test site actually work. So the main purpose is to test the RE and also the immunity test. So the key feature is basically you can see that we have a large, okay, you can see that we have a large area. We have an open space free from reflective object. Okay, you can see that there's nothing nearby. Okay, you can see that there's no building nearby. So the key idea to have this open area test site is the place need to be large. It must be open space, okay, without any reflective materials. Next, you actually can see a ground plane. Okay, so basically you can see that this is actually a ground plane. Same from here. So when you actually do this open area test site, you have a large ground plane, okay, which is just a simple conductivity surface, okay, so as to have accurate measurement. So this open area test site mainly is used for compliant tests per CISPR standard, FCC, and also the MIL standard. The limitation of this open area test site, okay, this is very severe, especially nowadays in Singapore. You can't hardly find any place that don't have any cellular service. So hence, when you actually use this open area test site, it is actually very vulnerable, very sensitive to ambient RF noise and also weather condition. Okay, so basically this is getting more and more challenging now. Okay, so basically we are moving away from this open area test site to something we call a control environment. Okay, so this semi-anechoic chamber is what we call a control environment. Okay, the key purpose again will be doing the same thing as the open area test site. So we'll be doing the radiate emission and also the radiate immunity. Okay, however, the key difference is use this specific word control environment. The feature, okay, you can see that we have absorber. Okay, from this diagram here, these are what we call the absorber. They have absorber that line the wall and also the ceiling so as to minimize reflection. Okay, so basically this absorber will stop the EM wave from multiple reflection. Okay, so this is the key purpose of the absorber. On the ground, they actually has this conductive floor. Okay, so basically it's the same as the open area test site. They have this huge ground plane, okay, as the floor on this semi-anechoic chamber. Mainly it is used for FCC Part 15, CISPR 22 and 32, and also Automotive EMC, okay, ISO 11452. Okay, so the key advantage, okay, when we actually move from open area test site to this semi-anechoic chamber is basically they are actually less sensitive to external interference as compared to the open area test site. Okay, so basically this is the semi-anechoic chamber. You realize that there is no so-called absorber on the floor. Okay, so for absorber on the floor, this is what we call a fully adequate chamber, as you can see from this diagram here. On the floor, there is no more huge ground plane, but simply absorber. Why we want to do this? Okay, the key purpose is we are going to do high frequency radiation tests, for example, 5G or millimeter wave. The key feature is we have all the absorber on all surface, no ground plane at all. The key intention is to do antenna measurements, radar, and also aerospace EMC testing. The key difference from this semi-anechoic chamber is there's no reflective floor. Okay, remember for semi-anechoic chamber, okay, on the floor is still a huge conductivity of ground. Okay, but for this case here, fully anechoic chamber, there is no reflective floor suitable for far field testing. Okay, so basically, in general, nowadays, EMC testing, for example, we want to go from low frequency to high frequency, you probably need to lay the absorber, okay, so on the floor, so as to move on to the higher frequency. So in short, semi-anechoic chamber still maybe exists for lower frequency, but fully absorber chamber are mainly target for high frequency testing. Next, okay, we have this shield room. Okay, so this is in fact the cheapest way to have a form of shielding. Okay, so this is not as stranger as compared to either the so-called semi-anechoic chamber or fully anechoic chamber. Okay, it's a very simple form of shield room. The key purpose is we just want to do a simple testing on conductor emission, conductor immunity. Okay, because conductor is mainly on cable rather than through the air. So therefore, we can afford to be doing all this testing in the shield room. Okay, so therefore, all this conductor emission, conductor immunity, even ESC, search EFT. Okay, so basically these are mainly can be performed in a shield room. The key feature, okay, you just have a simple metallic enclosure. Okay, in fact, is to block external RF interference. Okay, so whatever signal from outside, they will not be able to come inside the chamber. So this is often used for military mil-spec 461 medical IEC 60601 and also the industry EMC tester. Okay, the key limitation, okay, there is no absorber line out. So hence this is not ideal for any form of radiate emission and also maybe for radiate immunity also. Next, okay, we have this latest one, okay, which is the reverberation chamber, stir chamber here. So from here, you can see that why we have this EMC test facility, the key purpose is to have the high field radiation immunity testing, okay, for this standard here. IEC 61000-4-21. Okay, so what is the key feature? Okay, we have this reflective wall with rotating pedals to create randomized EM field. Okay, so basically you can see here, these are so-called the rotating pedals. So basically this thing actually will multiple reflection, and because of the multiple reflection, we can have very high field strength. Okay, because the signal keep on reflect, and they have this kind of reflective maintenance, and this pedal they actually turn in a random way. Okay, so as he mentioned here, so basically the reflective wall with rotating pedals, they actually create randomized EM field. mainly used for military, automotive, and also aerospace immunity testing. The key advantage is they can generate very high field strength, even more than 200 volt per meter. Okay, so basically, if you need to do testing under this radiate immunity, under this high field strength, then you can use this chamber to perform the tests. Next, okay, on the sixth, okay, which is the TEM or GTEM self. Okay, so basically this is for the key purpose. Okay, again, they are only doing for radiate emission and immunity, but for very small device. Okay, so basically the device that you're going to test, they need to be very small. Key feature, they are compact. They have this taper structure, as you can see from this G-TEM self here. They have this taper structure for controlling EM field. Okay, so they are mainly used for pre-compliant testing, okay, for IC level EMC and small PCB evaluation. Okay, so the key limitation is they really limited to very small EUT. Okay, so I believe that this kind of so-called EMC test facility more or less already phased up. Okay, so they are actually can be test just very small EUT or DUT. The last one will be the automotive EMC test facility. So these are mainly so-called the specialized to test for vehicle standard here. We have this ALSE, absorber line shield enclosure. Okay, so basically they are doing for radiate emission CISPR 25. Okay, so about the immunity, we have this BCI, bulk current injection. Okay, so if you keen to know this, we also have the series, okay, to let you understand how to do all this testing here. So these are the 7 common EMC test facilities. Coming to more detail, okay, so these are all the key standard and compliance. Consumer electronics, we have the FCC Part 15, CISPR 32. Okay, industry, we have this IEC 61000-6 series here. Automotive, we have this ISO 11452 and also CISPR 25. As for mil spec, okay, we have this 461 and D016 note here. Okay, the choice of EMC test facility actually depends on the product types, application standards, and also the required test level. Okay, large company and certified bodies often have these facilities, while pre-compliant testing can be done in smaller showroom or GTEM cell. Okay, before I continue, guys, I'd like to urge you guys to help this channel by like this video. If you have learned something from this video, again, urge you to help this channel by subscribe to this channel. And also, please remember to turn on your notification bell. Once again, thank you so much for strong support. Let's take a quick look, okay, on this open area test site. As I mentioned that you need to have a large open space. How large is what we call this large here? So this diagram here will roughly give you some idea, okay, how big the area you need to have in order to have this open area test site here. So this is where your EUT, okay, so this is where your antenna, okay, so basically, let's say you do 3 meter or 10 meter, so this is the distance D. So once you have this distance D, which is 3 meter or 10 meter, okay, so basically you need to have a clearance of 2D, okay, so which is 2 times, either is it 3 meter or 10 meter, you need to have the clearance over here. As for the other end, okay, you need to have a square root 3 times D. Again, okay, it actually depend on the distance between the DUT and also the antenna. So basically, this is the area size that you need to keep free of any reflective material or any other object that could influence the test result. Okay, so like I mentioned earlier on, this is getting more and more challenged. Okay, so this is for open area test site. Next, okay, so what is the big issue of this open area test site? As I mentioned earlier on, you probably have some wall. Okay, the wall can be so-called reflected by this wall and then finally reach the antenna. What we want to do is we want to have the direct line of sight of radiation from your EUT to reach the antenna. However, okay, because of open area test site, okay, for example, your monitor, they probably can radiate out, hit the wall and actually pick up by the antenna. This is actually unwanted reflection as illustrated over here. The one that we actually want is will be directly from the EUT all the way to the antenna. We also have any so-called another form of reflection is from the ground plane. Okay, let's say this is an imperfect ground plane. We have some issue. Again, the signal that is actually released by the EUT can bounce off from the ground plane and finally reach the antenna also. Beside that, for example, we have lots of signal in the ambient. We have mobile signal, we have FM broadcast, etc. All this can be an interference to the so-called test and measurement result. So this is the key issue with the open area test site. So how can we resolve all this? Okay, is to use a chamber. Okay, what is use a chamber? So when we actually use a chamber, okay, let me describe this. So these are what I mentioned earlier on. Okay, so this is an antenna. Okay, so basically this is a EUT. What we want is the direct measurement from the EUT all the way to the antenna. Okay, so but okay, certain thing may happen as you can see from here. Okay, for example, we can have tree, we have the ground, we can have even foreigner object that can cause so-called reflection. Okay, so you can see from here the original signal actually reflect by the tree and reach the antenna. The signal from the EUT actually reflected by a foreigner object and finally also reach the antenna. And this is basically also another so-called undesired reflection from the ground and finally also reach the antenna. What we want is basically this test signal path directly from the EUT reach the antenna. So all this we have the reflection. How to solve all this? Okay, so basically to solve all this, okay, besides all this, okay, so basically we also have interference everywhere. As I mentioned earlier on, for example, we have this FM broadcast, we have this cellular user, we have satellite communication. All this can actually create a source, okay, to create some so-called inaccuracy on the test and measurement result. So in order to resolve all this here, okay, so in order we want it to have this good test environment without reflection and interference, what we need to do is we need to have a chamber. Okay, so once we have this chamber here, okay, so basically whatever there is interference, they will not be able to come in. Okay, so basically this is a key thing. If we have this showroom, whatever there is the external, for example, as I mentioned, the satellite, they will not be able to reach the antenna. Okay, for example, the cellular, again, from here, you can see that they are not able to reach the antenna. Okay, for example, the FM broadcast, they will not be able to reach the antenna. Okay, but you still have the internal reflection, as you can see from here. Okay, we still have the reflection bound around inside. So how can we actually resolve this? Okay, so we can resolve this easily by having the absorber. So once we have this absorber, okay, this reflection inside the chamber will not be able to happen. Okay, so basically this is the idea, okay, on the EMC test facility, why we need to do radiate emission or radiate immunity in a controlled environment. Okay, so with this, I'd like to end my discussion. Please help to like and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.